are speaking through the puppet?
That has an invisibility cloak.
How do I know this is true?
I dreamed there was like probably running.
Just, okay, tell me this. Is 567 a Carmichael number?
20 years running from the boat.
Okay, I know it's true.
And then my mom
Okay.
turned
67?
This piece of
Or
chalk,
61.
567, it said
The
no.
fact that I was
Okay,
Harry Potter
cool.
had nothing to do with anything.
So we have to settle for the best we can do. So this piece of chalk,
Is now the puppet.
I mean, this piece of eraser is going to speak for the puppet. So the first thing you want to say is what? The puppet says it was studying this result
And fell asleep.
by Chipola and doing research in the library. How did it get into the library? It was closed after hours, huh?
It's a magical puppet.
Okay, we don't know, but it was in there, and it was proof, it printed. So it happened 110 years ago, in fact, on a beautiful spring day, somewhere in Brazil, I think. And a mathematician named Chipola in 1903.
Chipotle?
Chipotle?
Chipola.
Like the sauce?
C-I-P-O-L-L-A.
Oh, never mind.
Okay.
It's getting excited.
Was taking a trip to Brazil just to relax and to do some mathematics and just to, you know, have other ideas. Back then, folks were interested in more than one field. And what Chipola did is he was in a cabin in the woods, and he brought some supplies.
We're gonna draw a cabin.
No, well.
Thank
Yay!
And he brought supplies, and he, food and paper and pencil, and that was basically it. And he had an idea in his head, and this is the conjecture, and I'm going to do a time, you said it was. Okay, so some of the days, Chipola was keeping track of the time of the day. So I'm going to give you like a timeline sometime. So Wednesday, he arrived at the cabin at 4:20 approximately p.m. And this is 1903. I think it's sometime in the early summer. I don't know exactly when. Okay. And Thursday, he took the day to just go hiking and look for berries and find a water source, and he did.
You forgot an iron hiking.
And Friday, he decided to get down to work. So he sat down, and he made a conjecture, and the conjecture was, now keep in mind this is 1903, nobody knew about Carmichael numbers yet, but Courcelle already made the conjecture that Hannah and Page had, that the criterion that guarantees Carmichael numbers, but nobody actually
Wait,
knew one
how
existed.
could he have made that if there's no such thing as
Because you can, he knew that Fermat's theorem was around since the 1600s, and he knew if there was such a number.
So he invented Carmichael numbers.
He knew a sufficient condition for which a number would be a Carmichael
So-
number.
But there were no Carmichael
there were
numbers yet.
No
Carmi-
specific samples were known at the time.
Carmichael-
Late 1899, 1898. That's right.
Carmichael numbers were just like a theory at that point.
Right, right.
Oh,
If there was
so they were
such-
already in a concept.
Absolutely, but there was
They-
no sample found.
So there was no known Carmichael number.
Exactly. Not until 1910,
It's
Robert
just like
Carmichael
saying,
found one.
we know that this number exists, but we don't actually know
So they
what
weren't
it is.
called Carmichael numbers.
No, they were called babushka numbers.
Babushka.
Babushka numbers.
Babushka.
But
Babushka's
eventually,
different
they
word,
were
so-
called Carmichael numbers in his
Babushka.
honor. Okay, so let's go back. So he actually spent time, he knew Carmichael, and he made this conjecture. He turned the Carmichael concept, the babushka number concept around, and he said, is there a fixed number A for which there are infinitely many pseudoprimes? Because the pseudoprimes were known. All they are counterexamples to the converse of Fermat's theorem. That's been known. Fermat's theorem was from the 1650s, so people knew about the converse failing a long time ago. So for each A, this is just an idea in his head.